Well, hello everybody, and welcome back to G-Bear's Off-Grid Ways, Homestead in the Desert. And we got some things to cover today, so let's get to it. What we're looking at right there is actually a booster unit that I received from Verizon Wireless quite a while back, almost 2 years ago now. And what that does is, because I'm so far remote and I don't get a really good signal out here, they sent me that thing as a signal booster to pick up the microwave waves for the 4G and concentrate them and put them right inside my cabin where I get a better connection. And now all of a sudden my phone is saying 5G. So I don't think this thing will work, because this will only give me 4G. It won't give me 5G. So I'll have to contact them and see if they'll send me out a new 5G unit so I can swap this thing out. Anyway, I'm out here by the battery room because I've got a couple of questions I have to answer from a couple of my newer subscribers. And yes, I know some of this stuff I've already covered in older videos, but there's over 1,000 videos. I think I close going on 1,300 videos or something like that on my channel, and to save them the time of having to search through them to get the information they want, I just figure I'll recover it. For all those new viewers out there, they might be interested in this, and for you older viewers, this might be a recap. All right, so first of all, for Tony Johnson, he's asking me about my solar and how much solar panels I have. Well, my solar input is 3,450 watts total. Okay, so that's 3.45 kilowatts. And that's because I've just recently added these 6 panels right here, which are the big 305 watt panels. And these are 40 volts each. Open current, the VOC on them is 40 volts. Okay, so how did I connect them? He asked if I connected them in series or in parallel. Well, I connected them in series parallel. Yeah, series parallel. Okay, that's because I'll go over it in a minute when we get inside to the controllers, but that's because I wanted to keep the voltages down, the input voltage. You're not worried about the watts on these things. I mean, it's good to know that you got that many watts coming in. But your input to your controllers, the important thing is the maximum voltage and watts total that controller will handle. Okay, so that's why I had to do these in series parallel. And I forget if I did these in 2 sets of 3, I think is what I did. But then I have these Y connectors that join both sets together in parallel and bring it inside. And that keeps my voltage down because of the limits on my controller. Over here is these are mostly all 100 watt panels, and these are again hooked in series parallel. Now I've got these running all the way across here, and I got some up on the roof and some up on the roof and some over here. A mixed match of panels, but all the Harbor Freight solar panels, like those over there and 2 sets over there and the set up there and the set here, those are all going through Harbor Freight PWM controllers. Those don't tie into my good controllers, even though I could. They tell you on the Harbor Freight ones not to hook them in series, so I try to avoid doing that. Although somebody told me that they did it without a problem. It says don't do it, so I don't do it, all right? I don't want to waste my money and blow something up and say, oh, well, they were right. So anyway, back to Tony Johnson's questions. All right, so the thing is, you got to worry about your controllers and how much voltage they'll take. Now, right now, this is taking in 100.3, 100.7 volts incoming. Okay, but I've got it set up This unit will handle, this is the Midnight Classic 150. And the 150 means it'll handle up to 150 volts. But that's also plus your battery bank. So I have a 12 volt battery bank. So 150 volts plus 12, 162 volts maximum is what this will take in. That's the maximum I can put into it. So I didn't want to go up that high, so I kept it down to just closer to 100 and something volts coming in, so that I wasn't overhead. Now, right now it's in the float stage because everything, of course, is fully charged. I don't need any power coming in. The same thing here. And it's the afternoon. We're getting ready to go on sunset here. I know it's after 4 p.m. But these are both on float right now. Now, the Rover is an okay unit, but I prefer the Midnight Classics. And I recommend that if you want to make sure that you have a long-lasting controller that really, really performs and does everything that needs to do and is pretty much maintenance-free, go with the Midnight Classic. They make the 150, the 200, and the 250. And then the only thing the numbers mean is that they maximum amount of voltage input that you can have on them. So the 250 would be 250 volts plus your battery bank. So if you had a 24 volt battery bank, then you would have the 250 plus 24 or 274 volts allowed input. That's a good thing. All right. So these units are the best. I really, really, really love this unit. I wish I had the money to buy 2 more right now. I would, because they are so efficient. And these are able to handle either battery banks or PMA, wind turbine, or water turbines. They'll handle any one of them, but they won't handle 2 together. They're not Chinese hybrids like these things. Stay away from these things, okay? These wind solar hybrid system controllers are junk. They really are. Wind solar hybrid controller, MPPT, low voltage charging, they are junk. All right? Don't waste your money. Save the money, buy yourself a Midnight Classic, and you'll be so happy you did as time goes on. I ended up taking all of those out of here, and actually this PWM Windy Nation PWM actually outperformed both of those. So that's the way things go. And these are the Harbor Freight units. So you can see they're intaking 13.6, 13.7 right now. And I've got plenty of power coming in. So that's a very important thing that you want to know, is your panels can be hooked in series parallel, but just remember to keep track of your voltages. And Tony, you've been an electrician for 30 years, but you've never done solar. Trust me, it's not that different. And you're talking about your solar panels are your input power, just like your power lines. Coming through your meter to your electrical panel, it's your power. Your power comes from the panels themselves, okay? So the rest of that is the wiring. It's very important, very, very important. Get yourself a good controller. Get yourself a good inverter. Okay, now this is the AIMS 4000. This is a good controller. And why do I say that? Well, this thing does everything. And you see this heavy wire that's coming in right here? That's tied right down on those 3. And then up here I've got doubles coming out going into my electrical panel, because the opening for the wire was not large enough to put in a really large wire, but I could get 2 number 6s, one on top of the other, because of the width of the unit. I had enough room to get there with the screw open all the way up. So I did it that way. So I got 2 neutrals, 2 power 1s, and 2 power 2s. So I have 240 volts. This is a low frequency series. This is pure sine wave. This is the pure sine wave low frequency 240 volt split phase inverter. Okay, that's a SP for split phase. This is what I recommend if you're going to, especially if you do any type of handyman work, you run power tools out in a shop or something. This is what I would say to go with. But I would not go with the 4000 again if I had the opportunity to buy another one. I was in dire straits. My other Japanese or Chinese one actually failed on me. And it was a dirty sine wave, even though they called it a pure sine wave. They called it a low frequency split phase unit. And they said it was 8,000 to 32,000 watt surge. And then in little fine writing on the bottom of the label, it says, do not plug in anything over 2,000 watts. Come on, you know what? What a ripoff. But anyway, that's another story, another time. And that's what I had to face with that. So I was forced to go online and get a new inverter as fast as I could. And the only one I could find was the 4000 in the low frequency split phase. Okay. Now going back to this wiring, this goes to my generator out there. Okay, a 6,500 watt generator. And I keep the cable unplugged. Of course, you know, that's a whole nother story on generators about don't plug them in and then try to start the generator. You start the generator, let it warm up for a few seconds, and then plug in your wires to that. Never plug under load or unplug under load when you're ready to shut it off. You don't want to do stuff like that, okay? I mean, don't shut it off under load. You want to unplug it before you shut it off. And you want it unplugged when you start it up. Anyway, like I said, that's another story. I don't want to get too long on this video, so let's get back to where we were here. Okay, so remember that. Now, this rover, this does not handle the voltage that the Midnight Classic does. So I've got this one wired to the 100 watt panels, and I've got the voltage lower on that. Let's see if I can get to that. Yes, I'm only coming in at 50 volts on these because this one does not handle a lot of voltage. So remember that. Go with a Midnight Classic, and the 150 is fine. And then sooner or later you're going to see 3 of these here. This one will go away. It'll be used in my guest house cabin when I do build that. This one will be staying here, handling my 300 watt panels out there. And then right beside it, I'll have the other one handling all the other panels. And then right beside it, I'll have another one that handles my PMA, my wind turbine. Okay, so that's Tony Johnson. Let's move on to Northern Pike, because we're talking about PMA'S now, and he wanted to know about the wiring on a PMA. Okay, so PMA means permanent magnet alternator. Now, alternator is better than a generator because you can use smaller wires coming in. I'm using 10 gauge wire coming in. Okay, so I got them going through 3 lugs here into the unit, and then coming out of those lugs, they go into the bridge rectifier. Okay, a bridge rectifier, all that does is convert AC power to DC power. That's the red and the black coming out. Okay, so you're going to have 3 wires going in, which is AC, 2 wires coming out, which is DC. Now, from those 2 wires going out, you could go directly to your batteries. But I chose to add this little gauge on here so that it tells me what's going on here. It tells me my batteries are at 13.4 right now. It tells me what my maximum watt hours, amps peak, watts peak, amp hours, and all that stuff, all of that. Now this would be my watts input when the PMA is cranking, and this would be my amps input when the PMA is cranking. Okay, so you can see I just got a little bit of a surge there. There was a gust of wind out there, spun that unit and gave me a little bit of watts and a little bit of amps coming in. Okay, and this keeps track of the maximum amps and watts peak. Now you'll see on here that at one point there was 84.04 amps and 1200 and something watts coming in. That was during a windstorm. They're 1269. 1270 watts was the max coming in at one given point. So that's that. Okay, now the two wires going in, they're mocked input, and two wires coming out, one red, one black. They're 10 gauge, and they go through. I put this DC breaker in here so that I can disconnect it from the batteries anytime I want with a flip of a switch. That's all I put that in there for. Okay, but then it goes down to this one goes to the positive pole of the last battery. This one goes to the negative pole of the first battery. All right, it's that simple. But again, you could eliminate this part and just come straight out of the rectifier and go straight to your battery bank. All right, now I'm using a 12 volt battery bank, so of course I'm going to keep this on this 12 volt system going on this, and that's the way I run it. Now this is my dump load system. They don't sell these anymore, so don't go asking me where you can get one of these. Can you build your own? No. This looks like a Ford solenoid. No, it's not. This is designed specifically for this type of system, for a dump load system. It even has 2 extra lugs down here at the bottom. Now I've got these little wires tied in here that go to this fan. So when this thing clicks on, while it's engaged, it will heat up. It will generate heat because it's just an electromagnet in there under a spring load, and once it clacks into place, it's going to start getting hot. So this little CPU fan here will click on at the same time as this dump load clicks on, as when this PWM charger, when this PWM charger kicks on, it will turn the fan on and keep this cool. It'll blow cool air across it. All right. So all that you do with this hookup, and now they get rid of these PWMs, and they use a little digital diverter. Digital diverter is what it's called. Okay, so they don't use this type of system anymore, although you'll still see the solenoids in some of them. They're using a digital diverter unit rather than a PWM controller, because these things can microcycle and cause damage to your batteries. I've never had a problem, so I don't worry about it. Okay, so I have it running through a waterproof breaker here, and then that runs down to the negative pole of a battery, and then the positive side comes off here and runs down to the positive pole of a battery. And it looks like I'm going to have to do some cleaning down there and clean those cables off again and get myself some more terminal coating put on there. Anyway, that's how simple that is. All this does is it reads the voltage in the battery bank. When the voltage gets over the setting that's automatically put in this, and there is no way to change the settings on this. This is not a regular PWM charger like that. So this one doesn't have the 3 buttons on it like that does, where you can do adjustments on it. This basically is pre-programmed for the person that designed this dump load system, and they don't sell them anymore. So this still works for me. It never ever clicks on anymore, because this guy up here makes sure all the time that those batteries are protected and taken care of. It takes care of the microprocessor in that thing, takes care of those batteries 100%. It knows when they need power, it knows when they don't need power. It even knows when this one will go on equalize or boost, and this one will just go into a resting state, so that this one does all the work and it can rest. That's smart. That thing is like the boss of a giant corporation. It knows everything about its job, and it doesn't care about these little guys down here. Go ahead and do your thing. If that ever failed, this guy would take over and run whatever he had to run. And I just can't say enough about the Midnight Classic. Outstanding, definite top-of-the-line equipment. All right, so on the dump load, there's a that comes off of there. Let's see, what else did I have on here? Oh yeah, so this is coming off the battery, and then this one that comes off this side of the solenoid goes up to this load, which is basically a heating coil, and that'll heat up and get hot when there's too much power coming in on the PMA, and this one just runs to the negative pole of the battery, so it gives me a complete circuit. Okay, and I've got a 20 amp fuse in there just in case that blows up before this catches fire. It's a very simple setup. But if you want to put in a diverter, you won't use this type of dump load anymore. You'll use what they call a digital diverter unit, and you can find those online. I think eBay and Amazon both sell them, so you can go online and find them. All right, so that's about all I have for you today. I know this went a little bit long, but I did have to cover all of that. And before I close this off, I'm going to show you one more thing I did first thing this morning. I had an appointment to go to the head forestry department office and meet with a lovely young lady called Becca. Very, very helpful. And what did I get? Well, I got this, a military pass. Okay, so you hang this on your mirror, and this is good right now for the whole year. And what did it cost me? $0 for the military. If you want to get one as a senior, if you qualify as a senior, you can get one of these for senior, but it'll cost you $80 for a lifetime. So you pay one $80 payment, and that's it. You're good for a lifetime. So whenever you go someplace that requires a adventure pass for national parks and things like that, you just hang this in your mirror with this part where it says military pass and the expiration date and your signature on there, and that points out the window when you're hanging in your mirror. That's all you have, and you never have to go buy another one of those adventure passes. They're charging $5 a day for those. But if you are a disabled veteran, not only can you get this pass, but you'll get it for a lifetime. Now, as of next year, if COVID doesn't disrupt it, they will be issuing these from now on as a lifetime pass for any military. Okay, so I'm not disabled, but I am a military veteran, so I'll be able to get this as of 2023 when it expires. I should be able to get one that says lifetime on it, and that'll be free also. I'll still not have to pay for anything, but I won't have to go back every year to renew it. So anybody wants any more information on that, I can give you Becca's number here in California, and she can give you the information as to who you need to contact in your home state to get one of these things. Excellent to have, because if you don't have that pass in your windshield when you're out there in national park areas and all of that, it's a pretty hefty ticket. And that can really ruin your day. All right, everybody, so covered everything I needed to cover. I got a little bit too long in here, but I'm going to say thank you for joining me. Don't forget thumbs up. Don't forget to subscribe and share. Remember, I keep saying it, subscriptions are free. Doesn't cost you anything, and no, you don't get spammed. The only people that know that you subscribe to me and click the little bell icon are you and me. All right? That's it. Thank you. This is G Bear signing off.